Hello, everybody. Next, we are moving to the next topic, which is called as the need for modulation. Okay, that means why do we read modulation? Anyway, before we move to that, first let us use certain terminologies for defining our signal. Now, we know that there is a message signal which has to be sent. So, we take a carrier, and we put this message onto the carrier, and then we get a signal which is to be transmitted. So we get the transmitted signal. So both message and carrier comes into play. The message is also called as modulating signal. It's also called as a modulating signal. Why is it called as a modulating signal? Because the message modulates the carrier. Modulate means, as it is written here, regulate. Regulate means to change. See, when you have a fan regulator, according to your requirement, you will regulate the speed of the fan. Just like that, certain properties of the carrier are regulated. Which all properties? For example, the frequency can be changed, the amplitude can be changed, the phase can be changed. So either of these are changed or regulated based on the amplitude of the message signal. Okay, based on the amplitude of message signal. So based on that, when we do this modulation or regulating, we get the transmitted signal. So message is also called as a modulating signal, whereas the carrier is called as modulated, because that is the signal that is regulated or modulated. Okay. Now, why we require a carrier for sending this message is the reason for this topic, that is the need for modulation. Okay. So, since it's one of the most important topics, that is the reason why we are studying communication, we need to understand why do we need modulation. Basically, there are main three reasons, but here we will discuss four reasons, because the textbook that has been given as your reference, it has four major reasons. So I am putting the four major reasons. Otherwise, basically there are three major reasons. Okay. The three major reasons you will see one by one. So let us start one by one. What all are the reasons? First reason is that the distance that can be traveled by a signal in open atmosphere, that means in wireless condition, how far the signal can transmit is directly inversely proportional. Inversely proportional means you say distance travel, na? So distance is inversely proportional to its frequency. Now, when we say directly, we have to say frequency. So it is directly proportional to frequency, or it is inversely proportional to wavelength. Okay, let me use different kinds so that it's much clear for everyone to understand. Okay, so directly proportional to frequency or inversely proportional to wavelength. So the distance of travel is directly proportional to frequency, or distance traveled is inversely proportional to wavelength, lambda. And we know that f and lambda are opposing quantities. That means there is a general rule in electromagnetics that the speed of the electromagnetic wave is frequency into wavelength. So if you increase the frequency, the wavelength will go down. Why? Because c is basically the speed, which is the speed of light in free space. In free space, it's speed of light. In other medium, of course, it's less than the speed of light, but anyway, it's constant. In any medium, the speed of the electromagnetic wave is constant. So if you want to increase the frequency, the wavelength will go down, or if you want to increase the wavelength, the frequency will go down. That is the relation. They are related like that. Okay. So that's why when we are saying that it is directly proportional to its frequency, it means that the distance traveled is directly proportional to frequency. So if the frequency is more, it will travel that much more distance. Okay. So as you increase the frequency, it will travel more distance. Now if you are talking with the wavelength, then it is inversely proportional to wavelength. Inversely proportional to wavelength means distance traveled is inversely proportional to lambda. So if you want to travel more distance, then lambda must be small. The lambda's value should come down. Okay, or basically the frequency must go up. So if the normal wavelength is this, if you reduce the wavelength, okay, so I have reduced the wavelength, isn't it? It's not, I have not reduced the amplitude, I have reduced the wavelength. So if you reduce the wavelength, then it will travel more distance. And you know that this is low frequency and this is high frequency. Okay. Now, generally message is like speech, music. Okay. And what is the range of that? That range is basically 20 Hertz to 20 kilohertz. Human voice will basically go from 20 Hertz to almost 4 kilohertz. Not more than that. Then what about 20 kilohertz? 20 kilohertz is other noise that we hear, musical instruments and all those, they go beyond the 4 kilohertz range. Okay, so generally human voice is in this range. Now if I am trying to send this, it will go a certain distance. But now when I do modulation and I use a high frequency carrier to send it, for example, if you would go for any radio channel, you might have heard, Radio Mangalam, it has certain frequency. Let's say it's 91.2 megahertz. So megahertz means what? It's kilohertz here. Mega means 10 raised to power 6. So when you increase the frequency that much, that much more, it will travel more and more distance. So that is one of the reasons why we want to do modulation, and that is to increase the frequency of our signal, because our signal is generally in this frequency range of 20 Hertz to 20 kilohertz. We want to increase the range of the frequency, so we take it to this particular carrier frequency of 91.2 megahertz. Okay, so that is one of the reasons. What is the second reason? Okay, let me take a different color. What is the second reason? The second reason, as you can see, it's basically decided by the antenna. See, you might have seen many different antennas. All the antenna has a general rule that the antenna will work very efficiently if the size of the antenna is lambda by 4. That means whatever is the wavelength of wave that we are going to use, that wavelength divided by 4, that much distance, that much size antenna you have, then it will work the most efficiently for receiving as well as transmitting. Okay, so for radiation and reception, that means for transmitting and receiving the signal through antenna, the best wavelength would be a quarter wavelength. Quarter wavelength means lambda by 4. Okay. So now if I am having a 1 megahertz signal, and if I use the equation to calculate what its wavelength will be, using this C is equal to F lambda, where C is speed of light, F is the frequency, then lambda I can calculate as C by F. So C is 3 into 10 raised to power 8. Frequency is 1 megahertz. So if I use that, I will get the value of wavelength to be 300 meters. Okay. So 300 meters means 300 divided by 4 is 75 meters. So if I am having a message which is having a 1 megahertz frequency, its wavelength is going to be 300, and so for an efficient antenna should have 75 meters. 75 meters is a huge distance. Just imagine an antenna to have 75 meters, isn't it? Even that is a huge distance. So our voice is in 1 megahertz range? No, it's in this 20 kilohertz range. So let's take somewhere that our voice signal is 15 kilohertz. So again you try to calculate C is equal to F lambda, or lambda is equal to C by F. C is the speed of light, F is the frequency 15 kilohertz. You try to calculate it using a calculator. You will get the antenna length, quarter wave length, lambda by 4 length to be almost 5000 meter. That means 5 kilometer. So you require an antenna of size 500 meters for efficiently receiving a human voice signal, or even transmitting a human voice signal. You require 5 kilometer length of antenna. Okay, is it practical? It's not practical to have a vertical antenna standing on top of ground, having a height of 5,000 meter. Even Burj Khalifa is not having this much height. So you can understand that it is not very possible. Now if I go from 1 megahertz to 10 megahertz, if I go from 1 megahertz to 10 megahertz, then it becomes 7.5 meters. Now 7.5 meters is something understandable. But when I am talking about radios which go almost up to 91 megahertz, let's say up to 100 megahertz. If I would go up to 100 megahertz, you try to calculate, it will require an antenna size of 75 centimeters only. And that is okay. Okay, that is okay. That is something that we can have. So that is the second reason why we want to do modulation and take our signal, which is at a 20 hertz, 20 kilohertz range, to a very high value which is close to this 100 megahertz. You also try to calculate, see, our 2G, 3G communication, our 3G communication is generally in 3 gigahertz. Now don't think that it has been named 3G because it is in 3 gigahertz. It's third generation, that's why it is named as third generation. Okay, so our third generation mobile communication will have 3 gigahertz carrier frequency. 3 gigahertz means what? You try to calculate it, you will find that its antenna size will almost come in 15 centimeter. It will come almost in 15 centimeter. 15 centimeter is the length of the small scale, isn't it? And that is the antenna, that is why your mobile, less than 15 centimeter actually. So your mobile, that's why the mobile antenna, the size of your mobile is almost so small. If we are not in 3 gigahertz, and we are in this 100 megahertz range, then it's very difficult to have an antenna. That's why you will see the old police wireless system and all, it has a receiver with a long antenna. You might have seen people, pulling out the antenna, isn't it? The police officers, they are pulling out in their old wireless set, there is a antenna whose length is more. So why is that? Because they want to have an antenna of that much length, because then only the antenna will have an efficient radiation and reception. So this is the second reason why we do modulation and take our signal to a high frequency. Okay. The third reason why we do is because everyone is having the same frequency, 20 hertz to 20 kilohertz. Okay. Everyone is using this frequency range. I am talking to you right now, my frequency is between 20 to 20 kilohertz, not 20, actually 4 kilohertz. Anyway, so if I am playing an instrument, or if you are listening a music, that music will have this range, 20 hertz to 20 kilohertz. Now if I am going to take Okay, let me draw this properly. If I am going to take the frequency band, okay, suppose this is the zero frequency band, and this is 1 kilohertz or 2 kilohertz, and this is 4 kilohertz, then my voice will remain somewhere here. Okay, so this is going to be my band. Okay, this much frequency my voice is going to take. Now, if simultaneously someone else wants to send the signal, they also will be in this 0 to 5 kilohertz range, isn't it? So they also are supposed in this particular range only. Now, what is going to happen? Both these signals are going to be in the same frequency. Okay, what happens when everybody is talking? Nobody can listen to what the other person is saying, isn't it? Just same thing is going to happen. Just imagine you take your mobile phone and you are trying to talk and you can hear everybody else talking in that mobile phone. Why? Because all are concentrated in the same range of frequencies. All of them are lying in the same range of frequencies. So it will be as if you are not talking personally to a person in mobile, you are talking to a room full of people. And not also a room full of people, you are talking to a whole group of people. Generally, if you talk about a tower, a mobile tower will generally have or support at a time maybe 15 people, who are calling simultaneously. On an average, we will say there are 15 people simultaneously engaged in the conversation in a mobile tower. So just imagine you take your mobile phone and you are able to listen to all the 15 people whatever they are talking. Now forget about listen, you won't be able to understand anything because all the 15 people are going to talk together, isn't it? So what is required is that everybody should be kept at a different frequency. That is why we have this, in the radio we have a frequency designated to each and every person. A frequency is designated to each and every person. Now Radio Mango will have some other frequency, carrier frequency. Radio Mangalam will have some other frequency. Some Radio Mirchi will have some other frequency. So all are placed in different frequency. So if I am going to draw the frequency axis again, so now I will not draw this one. Now let me draw a different frequency axis. So suppose I am having a frequency axis like this, and this is the 0. Okay, I will take one particular frequency and I will put my radio channel around that. So this much bandwidth is now being occupied by, let's say, Radio Mangalam. Okay, so Radio Mangalam basically owns this. So I cannot put Radio Mango anywhere between it or near it. So I will give it or allocate a different carrier frequency for Radio Mango. Okay, Radio Mango. Similarly, for Vivid Bharati, I will use a different frequency range. So like that, the frequency range has to be different for different person. That is why we need to push all the signals that are actually working in the 0 to 20 kilohertz range. We need to take them and keep them separately. Okay, so if there is another person who is talking in the same channel, and I need to take it and place it in a different bandwidth. So like that, everyone has to be given a different bandwidth. When you are talking in mobile phone, in that tower, a 4 kilohertz bandwidth has been allocated to you at that time, and that is where you are being charged, or you have to pay money because you are occupying that particular bandwidth. Okay, you are occupying that particular bandwidth, so you have to pay them money. Okay, so there are lots of bandwidth available. Lots of bandwidth are available, and it is divided and given to different people. So I told previously of 15 people. So one person will be talking in this channel, another person will be talking in this channel, some other person will be talking in this channel. Okay, so everyone is talking in different channel. How? Because they all have been kept at a different carrier frequency. So all of them have been modulated with a different carrier frequency. That is why we need modulation, to take everyone and keep everyone in different bandwidth or in different carrier frequency. That is the third reason for modulation. Okay, what is the last reason? Okay, let me look at the last reason. The last reason is because as you go up in frequency, so as you go up in frequency means, see, if I am having a radio which operates in 1 megahertz, then it may have, maybe, let's say, so I am saying, let's say 20 channels, 10 channels will be there which can be occupied. Okay, you go further high, you go for this 100 megahertz range, you may have 20 channels available. Okay, why 20 channels? Because that many channels are available as you go up in frequency. Now if you go for 1 megahertz, you will again have, not 1 megahertz, if you suppose go for 1 gigahertz, you may have, let's say, 200 channels. If you go for 3 gigahertz or if you go for 10 gigahertz, the number of channels will keep on increasing. That is why when we are going from one generation to other generation, generally we are moving up in frequency. Okay, so now we are in 4G. When we go to 5G, we will go for another frequency. That's why you have this 2G mobile and 3G mobile. In old 2G mobile, you will never get the frequency spectrum of 3G mobile or 4G mobile. Why? Because the whole system has to be designed for that carrier frequency of 4G spectrum. Okay, so we are moving in higher and higher frequency. See, in optical, we are in terahertz. In optical communication. Okay, so optical communication is basically communicating with light. What is light? Light is another electromagnetic wave. Its frequency is in terahertz. So when we are operating in terahertz, the channel is almost like, huge number of channels are available. That's why when you are talking about your internet cable via wired connection, that means cable TV is through optical fiber, and you might have heard Asianet is offering optical gigabit, fiber and all. So why is this happening, this having so much huge bandwidth? Because it is working in a frequency which is in terahertz. Carrier frequency is in terahertz. That's why it has huge number of channels. That is why you will get more and more bandwidth. When we go from 3 gigahertz, or when we go from second generation 2G mobile to 4G mobile or 3G mobile, what happens? For internet, you will be allocated maybe 2 or 3 bandwidth simultaneously. You will be allocated so that you can use that much amount of internet bandwidth. That much amount of bandwidth you can. So if this bandwidth has to be made available, you have to have more bandwidth. So if you want to have more bandwidth, you go up and up. That is what the fourth reason is, that it helps, the modulation process helps in shifting the given message signal to very high frequency range, where where a channel will be occupied, will take only a very small share of the spectrum. Okay, it will take a very small share of the spectrum. So what is spectrum? So as I said, the lower frequency will have a certain spectrum range. So that can be divided up to 10 bandwidth. When you go to a different spectrum at a high frequency, there the number of channels will be huge. Why? Because the spectrum is large. So as you go up in frequency, the number of spectrums will keep on increasing. Okay, so these are the 3 main reasons. Let me again tell the reasons one by one. The first reason is that the distance traveled by a signal will depend on its frequency. If the frequency is more, the distance traveled is more. That was the first reason. Okay. The second reason was for having a very good efficient antenna, the antenna size should be lambda by 4 or quarter wavelength. And when you go for higher frequency, the value of lambda will go down. So the length of the antenna will go smaller and smaller as you go up in frequency. So it's always good to have modulation, which will take your signal which is in low frequency to high frequency. Okay. And the third one is that since everybody is talking in this particular range of 20 to 20 kilohertz, if everyone wants to listen to what the other person is saying, everyone will be allocated a different bandwidth. And so to take everyone to a different bandwidth, everyone should be given a different carrier frequency. And giving different carrier frequency means modulating in different carrier frequencies. So we require modulation for that. And the last one was, the fourth reason was, so that we, with the help of modulation, we go to even higher and higher frequencies, carrier frequencies, where more and more bandwidth is available. So these are the four reasons for which prompt us, or which urges us to pushes us towards going for modulation. Okay, thank you.